You know, it's funny. We look at our screens today, terrified and amazed by this thing called artificial intelligence, treating it like some alien invasion that just landed yesterday. But here's the controversial truth. AI isn't new, and it isn't magic. It's actually just a pile of sand, silicon, that we tricked into doing math using lightning. That's it. We took the most basic material on Earth, organized it into a complex architecture, and taught it to mimic the human soul. It sounds impossible, a total paradox, right? But the story of how we got here is full of failures, broken dreams, and a few stubborn geniuses who refused to give up when the world told them they were crazy. I know it feels overwhelming right now. You open your phone and see a computer writing poetry or passing medical exams, and a part of you wonders, where do I fit in? That fear is real, but it comes from not knowing the full story. We often think technology is a straight line of success, but the reality is a messy, chaotic evolution full of dead ends. Understanding this journey isn't just a history lesson. It's the key to mastering the future instead of fearing it. If you understand the foundation of the machine, you stop seeing a monster and start seeing a tool, a powerful lever for your own mind. So I want you to forget the hype for a second. Forget the robots taking over the world. We are going to go back to the beginning, to a time when a computer was the size of a house and couldn't even beat a toddler at tic-tac-toe. We're going to see how we moved from brute force calculation to genuine creativity. By the end of this, you won't just understand ChatGPT. You'll understand the very spark of human ingenuity that made it possible. Let's find out how we taught a rock to think. Imagine a brilliant mind trapped in a room with no way to speak or move. That was the state of computing in the 1940s. Alan Turing, a genius far ahead of his time, dared to ask the forbidden question, can machines think? He laid the theoretical foundation for everything we use today, but he was like an architect with a perfect blueprint and no bricks to build with. He had the logic, the pure mathematical beauty of a thinking machine, but he lacked the physical muscle to make it real. It was a brain without a body, a ghost in a machine that didn't exist yet, waiting for a spark to bring it to life. Then came the hardware revolution, driven by a brilliant but difficult man named Bill Shockley. Before him, computers ran on vacuum tubes, giant, hot light bulbs that burned out constantly and took up entire rooms. Replacing them with the transistor was like swapping a raging bonfire for a tiny, cool LED switch. It changed the entire architecture of technology overnight. Suddenly, you didn't need a warehouse to house a calculator. You could fit the power of a city block into something the size of a fingernail. This was the moment the physical limit of computing was shattered, allowing us to dream bigger than ever before. But genius often comes with a price, and Shockley's team couldn't stand working for him, leading to the famous traitorous 8 walking out. This rebellion wasn't just office drama, it was the birth of Silicon Valley and the creation of the integrated circuit. They took those tiny transistors and packed them onto a single chip, shrinking computers from warehouse-sized monsters to desktop companions. This evolution meant that computing power could finally leave the lab and enter our homes. But even with all this power, the machines were still missing something crucial. Back in the day, people looked at computers and thought they were seeing magic. But honestly, it was just a calculator on steroids using raw calculation power. Take the famous match in 1997, where IBM's Deep Blue crushed Garry Kasparov at chess. It wasn't actually thinking or plotting like a grandmaster, it was just crunching numbers faster than any human brain could ever hope to. It felt like a massive victory for machines at the time. Yet looking back, it was really just a brute force attack on a board game. It's like watching a bodybuilder lift a heavy truck. Impressive, sure, but ask them to thread a needle with those shaking muscles and you see the limit. Think of those early machines like a honeybee in a garden. A bee is an absolute genius at finding flowers and making honey, doing that one specific task better than you ever could. But ask that same bee to drive a car or tell a funny joke, and it's completely lost. Deep Blue was a master of the chessboard, a perfect screwdriver for a specific screw, but it was useless if you needed a hammer or a wrench. It was narrow AI, brilliant in a box, but take it out of that specialization, and it falls apart because it lacks the flexibility of a human mind. We hit a massive wall because these computers were fast, incredibly fast, but they were dumb as rocks when it came to learning. They could only follow the strict rules humans typed into them, line by line, never improvising or adapting to a new situation like a child does when they touch a hot stove and learn not to do it again. We had built speed without wisdom, and everyone started wondering if we'd ever figure out how to make a machine actually learn from its mistakes, or if we were just stuck with really fast calculators forever. While everyone else was busy writing strict rules for computers, a guy named Geoffrey Hinton was quietly obsessed with how the human brain actually works. He didn't want to just program a machine. He wanted to build a digital mind that mimicked our own biology, creating what we now call neural networks. It was a lonely road for him because most people thought he was chasing a ghost, but he knew that true intelligence wasn't about following instructions. It was about recognizing patterns. He saw the potential for machines to connect dots, just like we do when we recognize a friend's face in a crowded room. Imagine a student taking a difficult math test, but instead of solving the problems, they just guess randomly because they don't know the method. Early AI was that guessing student, but Hinton introduced a concept called backpropagation, which acts like a strict but helpful teacher standing right over their shoulder. Every time the student gets an answer wrong, the teacher points to the specific error and says, "You messed up here, adjust your thinking by just 1% to the left." It's not about getting it right instantly. It's about that tiny, constant adjustment that eventually leads to mastery. Over millions of these tiny corrections, that student stops guessing and actually starts knowing the material inside and out. It's the same way you learn to shoot a basketball. You miss, you adjust your aim, you miss again, you adjust your knees, until swish. It becomes muscle memory. This process turned computers from rigid rule followers into adaptive learners, capable of improving themselves without a human typing in every single command. But even the smartest student needs a massive library of books to study from, and that was the one thing these digital brains were desperately missing. Imagine trying to drive a Ferrari with absolutely no gas in the tank. That was AI before the internet exploded. Suddenly, we had mountains of data, photos of cats. In cars, sunsets, which became the high-octane fuel these systems desperately craved. But fuel isn't enough. You need a powerful engine to burn it efficiently. That's where video gamers accidentally saved the day, because the same chips used to render explosions in Call of Duty turned out to be the perfect hardware for crunching the massive math needed for deep learning. In 2012, a competition called ImageNet changed everything, acting like the Olympics for computers trying to see the world. Most teams were still using old-school tricks, trying to manually describe a cat by its ears or whiskers. Then, Hinton students walked in with a secret weapon, a neural network running on those video game cards. They didn't just win, they obliterated the competition, proving that when you give a machine enough examples and the right processing power, it can figure out the rules of the universe all on its own. This wasn't just a tech upgrade, it was the moment the machine actually opened its eyes for the first time. It stopped just doing math and started perceiving reality, distinguishing a strawberry from a sports car, not because it was told to, but because it saw the difference. It was like watching a child suddenly understand that a drawing of a dog represents a real dog. But seeing the world is one thing. Understanding the complex, messy language we use to describe it is a whole different beast. Imagine trying to understand a complex story if you could only see one word at a time through a tiny hole in a piece of paper. That's how old language models worked. They'd get to the end of a sentence and completely forget who the subject was at the beginning. But then, Google's researchers had a massive breakthrough in 2017 called the Transformer architecture. It wasn't just a software upgrade. It was like giving the machine a photographic memory for context, allowing it to see the whole picture instead of just a tiny slice. Think of it this way. Old AI was a slow reader, struggling to keep up. The Transformer is like a supernatural librarian who can read every single book in the library at the exact same moment. It doesn't just read, it understands how a word on page 50 relates to a word on page 200 instantly. This ability to pay attention to everything at once meant it could finally understand nuance, sarcasm, and the messy way humans actually talk to each other, rather than just spitting out robotic answers. Then, a group called OpenAI took this incredible architecture and decided to feed it the biggest library in existence, the entire internet. They poured in billions of words, conversations, and articles, training it to predict not just the next word, but the next thought. When they released ChatGPT in 2022, it felt like magic to the rest of us, but it was really just the result of that massive scale of learning. We finally had a machine that could talk back, but the question remained, was it actually thinking or just mimicking us really, really well? So, we've traveled from clunky vacuum tubes to the mind-bending power of the Transformer, but here is the reality check. We aren't just looking at history anymore. We are living in the intelligence explosion right now. We have moved past simple chatbots to the doorstep of AGI, where machines can diagnose diseases, write code, and reshape the entire global economy. Just look at how NVIDIA and the tech giants are fighting for dominance over this new infrastructure. The evolution hasn't stopped. It has accelerated to a point where the tool is becoming a partner. The question isn't, can machines think anymore? The real question is, what are you going to do with them? You are standing in front of the greatest opportunity in human history. You can be the person who watches this transformation from the sidelines, paralyzed by the speed of it all. Or you can grab this capability and use it to build the life you've always wanted. Are you going to let this moment pass you by? Or are you going to learn to speak the language of the future? Don't let the fear of the unknown stop you from mastering this potential. If you want to stay ahead of the curve and truly understand how to navigate this new world, make sure you subscribe to the channel and turn on notifications.